And now the final question, question 12, this is the tricky one. A bicycle wheel has a diameter of 34.3 centimeters. So I've got a bicycle wheel. First of all, they're giving me the diameter, so you're going to have to cut it in half to get the radius. And it's got a mass. It's placed on a stationary stand on rollers, and a resistive force of 137 newtons is applied to the rim of the tire. So it's got a force this way of 137 newtons for me. And all the mass is concentrated on the outside radius. In order to give the wheel the acceleration, what force must be applied to a chain passing over a sprocket with a diameter of 12.4? Well, here I've got a second thing that I've got to worry about, and I've got a sprocket that's going to be located right here with a different radius. And again, they give you the diameter. So I've got a rope that's going to be pulling here with a certain force that's going to be trying to accelerate the wheel in this direction, and yet I've got a resistive force here that's trying to decelerate. So this is an example where your net torque is going to be your moment of inertia times your alpha. They give you the alpha, so that's good. Your I is going to be a bicycle wheel, so all the mass is on the outside, so that becomes mr squared. So you've got mr squared alpha on this side. But the net torque is the tricky part here. So what does mr squared alpha equal? Well, I'm going to put net torque on the other side just to make it easy to write. The net torque is the difference between the positive torque, which is going to be the force that's applying on the sprocket, and I'm asking, actually, what force must be applied to the chain. So that's the force I'm looking for, times the smaller r, which will be the radius of the sprocket. So there's RF for the torque, RF, minus the RF of the bicycle wheel. And so that's going to be the full radius of the wheel times the force that is the restraining force. So this restraining force of 137 newtons for me is going to be this force. This radius is the full radius of the bicycle wheel, which is half the diameter. This radius is the radius of the sprocket, and this force is the force you're looking for. So you know mr squared alpha equals the net torque, because the net torque, just like the net force would accelerate a mass, the net torque is going to accelerate the moment of inertia. I think you have enough to solve that one. And that's it. So good luck with this homework.